Hello again. I want to do some more examples with arrays. And actually, I'm leading up to something you're going to need for your next project, your next lab or homework. So here's the problem I want to do. Given a list of integers, positive integers, let's say, sort the list in non-decreasing order. How that means is that if I say in increasing order, then I've got problems when I have two numbers that are the same. When I say decreasing order, that covers that case. All right, so that's what I want to do. Now, if I want to do that, I want to test this. If I want to test it, I need something to test it on. So an earlier or a sub-problem, let's call it, create a file of numbers to test the sort. I don't feel like typing in a lot of numbers, so I'd like to just create a set of numbers. Now, I've already done that, and I'm going to bring up the program, and we're going to talk about it. So this is not the program. That's the second one we're going to look at. Create random file of numbers for sort, and I typed the R when I shouldn't have. The first part's easy. Again, the time and the standard lib are needed so I can do my random. And IOmanip is so I can get a good output on the screen. And fstream is because I needed an output file. As I did once or twice before, I'm using const. What const is it gives me the chance not to have to keep rewriting the whole program if I want to change how many things, how big I want my list to be, how many things I want for the list of what numbers I want to work with. I put two constants in. Remember that the syntax is the word const, the type of the variable, the name of the variable, and then what its value is in this particular program. That means that every time I write num, I'm really writing 1,000. But if tomorrow I decide I want to go to 5,000, that's the only line I have to change. Everything else will follow that change. One line has to be recompiled, but I don't have to rewrite line after line after line. Now I'm going to create a variable, an array, and notice I put num in as the number of elements. I can do that because num is a constant. So that's just the same as saying int val's 1,000. It's a nice way to set up an array for many problems. I have my usual output stream, my usual open for it. Now, here's what I'm going to do. I'm going to initialize those 1,000 numbers. You notice I don't have an equal brace something. I'm not about to type 1,000 numbers there. What I'm going to do instead is I'm going to put the numbers 1 through 1,000 into those into that array. So vowels 0 will equal 1, vowels 1 will equal 2, vowels 2 will equal 3, and vowels 999 will equal 1,000. Remember again, we count from 0 to 999 if we have 1,000 elements in our array. This is just a way of initializing. It's like I'm buying a new deck of 1,000 things, and they're numbered 1 through 1,000, so I can work with them. I have unique numbers there. Now I want to rearrange them. I want to shuffle them. This is where we're going to be getting into probably the next lab you have. If you hear the word shuffle, you probably think of a deck of cards, unless you are a movie fanatic or a musical fanatic and think of Shuffle Off the Buffalo. But I doubt that. It's probably only me that could think of that. So we're going to be, this is going to lead up to a program to shuffle a deck of cards for something that, and then continue from there. So as usual, I do the SRAN. Now, once more, this has come up in some of your programs. SRAN is done once. It's like buying your sequence of numbers to work with. All it's saying is, I want to work with a sequence of numbers. Would you start them out for me? And do it randomly. Just base it on the current time. And the time is in such minute units that I can't predict it. It'd be very hard for me to predict it exactly. So that is done once. And all it does is say, I'm starting out. Don't put it inside loops. Now I'm ready to generate. What I'm going to do is I'm going to shuffle a deck. I'm going to shuffle these 1,000, in this case, cards. I'm going to use a simple trick to do it. When you think of shuffling, all it really is taking one card here, another card here, and switching them. That's the essence of shuffling. Now, of course, you do it in a fancy way, and some people are really good at it. I'm not. But that's what you basically are doing. You're taking one card, another card, and you're exchanging them. So all I'm going to do, I chose 5,000 to do it 5,000 times. I tried 500. I didn't like the result. I really don't think I needed to go to 5,000. So I'm going to make 5,000 exchanges. I'm going to pick two numbers, first and second. You'll notice they go from 0 to 999. No adding 1. I don't need to. What I now want to do is exchange card first with card second. I am not exchanging the numbers first and second. I'm changing whatever is in those locations. In the beginning, you'll be able to tell, but this is going to keep moving around and around and around. So I make the exchange the usual way. Right there, those three items are the exchange. That's it. Now, I don't want 1,000 numbers to work with. That might be a little too big. So instead, I've decided I want to pick a smaller number of them. How many? Whatever that is. I picked 16. And what I'm going to do is print those out and print them out to the file. I already created the file. So what I'm going to do is I'm going to copy this program for you over to here in case you want to create a file yourself to work with. I do think that you won't have as much trouble doing this on the Mac because these are numbers. They're not strings of characters or whatever. I think they'll be easier to work with. But there's what I have, and here's what the file looked like when I finish with it. I'll open the file now for you. It was called vows. And this is what I got as an answer. So my answer, my file, was, it's a reasonably random file if you look at it. The only thing that surprises me is there aren't any really low numbers. But otherwise, it's pretty random. So that's the file that I'm going to work with. Now, I have sorted, I've got my subproblem done. Now the problem is I want to create an algorithm to sort. As John Seifert once said in one of his videos, he has a book of these algorithms. It's true. One of our greatest computer scientists, Donald Knuth, wrote a whole book on sorting and searching. And it's a huge book. People have been trying since the beginning of computers, or even before, to find fast ways to do these things. Sorting list and searching list is one of the major uses of computers in business. Just even for us in the academic world, every time you call the dean will ask you for a your student ID. He's using that, or she's using that, to search the list she has of your, and the list is ordered probably by student ID. It may be ordered by name too, I'm not sure. So searching and sorting are very important. I'm starting with sorting because when I do searching, I want to have a sorted file to search. Now, as I said, there are so many algorithms. I'm using one that I call bubble sort, but I don't know if that's the official title. I'm going to do bubble sort. And just to help you, I'm going to do an example. I'm going to suppose I have these numbers: 16, 41, 12, and 8. Only 4 of them. That's my list. If you want me to put that in a list, I can do it this way. I can insert a table, 4 elements. How did I get 3? Well, that's okay. So this is place 0. This is place 1. Place 2. Place 3. In fact, it might be better if I call them by that. I'll call them by name list. List bracket 0. List bracket 1. List bracket 2. 2, and list bracket 3. And I don't need this last row, so let me get rid of that. Delete entire row. Now I'm going to put these numbers in. There's the value 16, that's the value 41, that's the value 12, that's the value 8. So that's what we start with. So if you were to print out list bracket 0 bracket, you get 16. Now here's my plan. I plan to put the smallest value into list 0. That's my first step. Now, how am I going to do that? Well, let's see. I'm going to compare list 0 to list 1. And exchange if they are not in order. And I'm using order as going up. If not in order, so I can get it on one line. Now in our case, this won't, there'll be no exchange. So now I'll compare list 0 to list 2. And exchange if not in order. So I'm going to go up here in the example. 16 is compared to 41 and no change. In the next example, in this case, in the example above, we compare 16 is compared to 12 and exchange. And that means we have a new result. This is the result we get when we do this. The 16 is replaced by 12, and the 12 is replaced by 16. So we're not finished, of course. After all, we still haven't got the smallest one in there. But we got a smaller one in. The next thing we do, and that ends that particular example part. Now I'm going to compare list 0 to list 3. And again, exchange if not in order. Now in our case, we will be comparing we'll be comparing 12. And I'll put in the example again. In the example, compare 12 to 8 and change. And now what I'm going to get, remember this is the 16 is here now. And I'm exchanging the 12 and the 8. So I'm putting the 8 here and the 12 here. At that point, I have smallest in list 0. It has to be. I compared it every time. I took the smallest I had found so far and compared it to the next one. Now, if you are thinking, or perhaps I hope you're thinking, you might say, well, where does this go now? You put the smallest into list 0. Maybe we should look at list 1. Maybe we want to get the smallest in list 1. So the next step is put the next smallest in list 1. And we're going to do it the same way. We're going to compare list 0 to list 1 now, no more 0, to list 2, and change if needed. I'll make it smaller. In our case, in example, compare 41 to 16 and change. So again, I'm going to show you the result of that. I take that, I'll put it down here, and now what I'm doing is exchanging 12 and 41. And that's what I've got. Now I'm going to see if I can make this a little bit smaller so I can fit more on this page. Let me try 12. Well, your eyes can probably see that. Mine probably can't. So let's go with 14. I hope that's readable to all of you. Well, we're not really finished. We really have to check. We have to compare list 1 to list 3 and change if needed. Well, in our example, we compare 16 to 41 and no change. Now, you might say we're done, but that's accidental. I have never compared 16 to, pardon me, we are done. No, we're not done. It's possible. I compared 40, this is the mistake I made. I had to compare 12 to 41. No, 12 to 16, pardon me. What I did wrong was I forgot to put the 2 here. And we had no change. Well, we're almost done. Now, put the next smallest in list 2. And again, it's the same thing. Compare list 2 to list 3 and change if needed. In example, no change. we are, in our example, we are comparing 16 to 41. No change. Now we are done. We have first three in order. Well, that means the fourth one's got to be in order. There's no other way. We only have one left. And it's bigger than anything that was there so far. So we are done. Now, I went through this in great detail because I want you to think about how you develop algorithms. This is how you have to do it. You have to think out how you would do it by hand. And then you have to look for loops. Well, I conveniently put a few loops in here for you. I see a loop where I put the smallest in list 0, the next smallest in list 1, the next smallest in list 2. When did I stop? I had 3 elements, and I stopped when I got list 2 into place. Well, if I had 10 elements, I could stop if I have list 9 in place. And if I have n elements, then it'd be n minus 1. And now, what do I do in each of these passes? I'll call them passes. Well, when I started with 0, I compared list 0 to list 1, list 0 to list 2, and I am in the and list 0 to list 3. Notice I went to 3, and there were 4 elements in the list. When I had 1, I compared it to 2, and then to 3. Pardon me, it was supposed to be 3. And I should have put this in the same size that the rest is in. So I went from 2 to 3. When I had 2, I again compared up to 3. So it looks to me like what we're seeing here is something along the lines of 4 0 to the next to last element, compare the, I'll say, for n equals 0th element to the next to last element, compare the nth element to elements nth element. Well, let's write this a little different, pardon me. I'm going to say for the elements n plus 1 to the last element, so we'll call those for x equal the n plus first element to the last element, compare list n to list X. So that's the way it works. Now you have to think that the last element, remember, is not n. It's list n plus 1 if the size of the list is n. So if the size of the list is size, then the last element is size minus 1, and the one before that is size minus 2. And that's what I did with this loop, if you look at it. Let's go back here. Oh, that was, now I got to bring up the other program. So here is the actual sort. No random needed here. Again, I use the same numbers as I used when I created the file. And again, I created a list, and I put paths in to make it easier so we can see what's happening. First, I read the file. And then I said, let's print it out. I want to see what it looks like. By the way, notice this pass plus plus. What this is saying is, after I use pass in the function, now add 1 to it. So I'm not passing the pass plus 1. I'm passing pass, and then plus plus should be done after. I think. I hope I got that. I know I have it right in most cases. I've never tried it. It seems to work here, so I don't think we have a problem. Now I just go through the loop. I call them first and second. First goes from 0 to how many minus 1. And then I go from first to 1 to just before how many. Notice these are less thans. So this goes up to how many minus 2. This goes up to how many minus 1. And each time, if there was an exchange, I printed that out for you. And then I did the actual program. I wrote a printer routine because I just did not feel like typing that all the time in all the places I needed it. I'm going to copy this program for you. Put it over here. So the program is, and now make it bigger, and I'll show you the result. So let's run it, and I'll copy this for you too. I hope I can get it all in. Yes, I can. It might be hard for you to see it when we do get it in, but I'll try. Oh, come on. Control C. Control C. And back here. There it is. Pardon me, I have to bring up the right one. And here's the result. And that's it. Now let's look at what this is doing. Didn't come out perfectly because the sizes are not right. To get the sizes right, I'm going to have to take it down smaller again. Didn't look that long when I did it over on the other side. All right, let's bring it down. To 12. Still doesn't fit in. I don't think I can get it much lower than that. Oh, I didn't give it any number. That's the problem. Well, that's nice. I'm trapped. No, not. Oh, there it is. It did do 12. I thought 12 might work. In fact, it's conceivable that 14 might. Nope, 12 does. I know this is small, but you can increase it when you get it. Here's past 0. I started out with them, nothing has happened. Now, in past 1, there was an exchange because 614 had to be exchanged with 244. So you can see the exchange. Then 244, which was now here, was smaller than 148. So they exchanged. And now 148 was smaller than 113. So they exchanged. And now 113 wasn't smaller than anything else. 113 is in order. Now I work on the second one, 617. It immediately changes with 614. I think. Yeah, it looks like it did because that was the one next to it. Then 614 it changes with 244. And then 244 it changes with 189. 189 it changes with 148. And 148 exchanges with 132. And now we have the first 2 of them in order. Now that's a lot of times, a lot of exchanges. I'm not calling this cheap as an algorithm. It takes a lot of exchanges. So that's where I want to go right now. I'm going to put another video together, perhaps later tonight or tomorrow, where I'm going to search in that item. But I want to show you a little trick or something, what I'm up to. I want to look at this one. Suppose I changed num to 52, and I changed how many to 52. Then I'd start out with an array of numbers from 1 to 52, and I'd shuffle them together and end up with 52 numbers, all different. Now, 52 is the number of cards in a deck, in most card decks. And when I'm rearranging them, I'm essentially shuffling that deck. So if I represent the cards in the deck as 1 to 52, then I've got a shuffling program. The next step is, I don't really want them to be 1 to 52. I want them to be like the king of hearts, or the ace of diamonds, or something along that line. So that'll be our next step. In the next video, I'm going to do the search algorithm, and then I'm going to do setting up the shuffling and turning a deck of cards numbered 1 to 52 to more convenient ways of looking at them. So long now.